Welcome to the first video presentation of the C160 Transall by AzurPoly. My name is John, callsign Max, and I'm going to guide you through the first walk around of the aircraft to introduce you to the external model of the aircraft and some interesting features. So we're going to simulate a walk around first to let you appreciate this model. So we're going to make sure that all the pitot covers has been removed. We are going to let them on intentional purpose for aesthetic first. So here is the inspection light. So bulb is clear, glass is clear. We make sure that all the covers has been removed on the iPad AzurPoly that's available on the cockpit. Then we are going to inspect the nose gear, so the strut is good, no hydraulics leaks. The tire inflation is great. Make sure also that the nose wheel is facing forward. We're going to look at the radome of the aircraft. So the nose is properly not damaged, clean. Let's look at the windshield also over there. And the wipers are in place, glasses are correct, the refueling probe is intact, no damage visible. Also make sure that all the maintenance traps are closed and flush with the aircraft. We'll also make sure that the probe's covers are removed on this side also. Glasses are clean, not damaged. Here also the wing inspection light, the probes not obstructed. Make sure that all the propeller covers and protection has been removed. Props is clear of ice, no damage. The prop cone is also in place and in a proper condition. Then we're going to inspect the Tyne engine. Make sure that every covers has been removed. There is no fuel leaks, hydraulics leaks from the covers. And we're going to look at the main gear. One of the interesting features of the Transall is that we have what we call the fuselage can be lowered to facilitate cargo operations. So now it's in the lower position, and that can be changed on the iPad from AzurPoly or the switch on the cockpit. So right now we can look at the main gear. So proper inflation of the tires, no fuel leak, no hydraulics leaks. Then let's look at the wing condition. So clear of ice, landing light in proper condition, no maintenance traps and openings there, no leaks everywhere. Then the lights, everything seems in order. Antennas, we're going to look at the ailerons, no leaks, a proper visual verification. Here the spoilers, no leaks, everything seems in place, in order. The back of the Tyne engine, so the exhaust, that should be removed, no leaks. The flaps, everything's in order and clean, look correct to me, even if it's just a simulator. The antenna is not broken. Then we're going to inspect the doors, make sure that everything is flush, just to limit the drag and make sure that pressurization will be done accordingly. So door is flush. Here is the paradrop door on the right side. Then the antennas, then the de-icing boots are normal and intact. Fuel dump not obstructed here, and all the controls are in order. Now we're going to walk inside the cargo and make sure that everything is in place also. So watch the step. As you can see, there is a good job of texturing here. So we open via the iPad AzurPoly the left door for the parachute drop, whatever. I don't know the term precisely, but the door is open, and in flight it makes a great view for you to enjoy and try to jump out of the aircraft, even though we do not recommend it if you are in the controls of the aircraft. So we can change the loadouts of the cargo by going to the iPad in the cockpit. So basically this is load master, very simplified stuff. So you can click on whatever load you want. So we are going to put some barrels, some pallets. You can also add some vehicles that has been transported by the Transall. So you can see some pallets, some loadouts. You can change them, of course, depending on the mission you're going to fly. Then you can get out like airborne paratrooper. Be careful of your knees, of course, while descending the aircraft. And we're going to continue the walk around. So basically it's the same as on the right side. You're going to inspect no leaks. The general spec on of the controls. Everything seems in place and all the covers has been removed. So the covers can be removed also via the iPad from AzurPoly. And now we're going to go back inside the aircraft to do the interior walk around. So now we are inside the cockpit. We just got in from the exterior. And we are going to do a basic walk around, but inside the cockpit. So we're going to do this on the seat of the flight engineer, because it's going to give us the best view, I guess. So as you can see, we can adjust our seats. So we're going to adjust ours and do a kind of fast explanation of the systems of the aircraft. So as you can see, all the seats have been modeled. So in future update, we are going to implement the navigator location. So as you can see on the captain side, we are going to have a EADI, EHSI, as well as standard instruments, indicator, the speed, angle of attack, altitude, and radio altimeter. Everything to do a proper IFR flight. Here, you are going to have the landing gear levers, as well as the trim here, like the real aircraft is connected to the control column. We can also open the windows and gather some options on the AzurPoly iPad. You're going here to have some different gauges underlined by some colors. So as you can see here, the yellow color are underlining the fuel systems. Here you can see the pressures of the fuel, the quantity, and the fuel flow. Here is the power settings. You can have the RPM, the water methanol injection. Here you will have some oil indications, and here a weather radar, which is not implemented yet. Here you have hydraulics system, so you have the blue hydraulics, the green one, and the emergency red one. Just monitor this if you want to have some powered controls. In white, you're going to have the APU gauges, the RPM of the APU temperature here, and the layout of the copilot, which is basically the same as the captain side. Now we are going to move to the center pedestal, and we are going to look at fuel systems here. So we are going to have here basically the fuel pumps for our two engines. Here are the start lever valves, which are going to help us start the engines. Here is the anti-skid, which is called mini stops, the fuel pumps for our left engine and our right engine. You are also going to have here the main general engine starter and the two igniters. So this is a pretty complex aircraft to start, you will see. Basically it's operated by 4 people, and you're going to have one guy to operate it on the sim. Here is the APU systems and the propeller test switches to test the systems also. Here we are the condition levers. Basically the condition levers are going to change the fuel flow on the aircraft as well as the prop pitch. We're going here to have 2 FMS. At first we are going to have very basic pages like the comms pages, which is very useful of course. And after we'll implement many other features. Here is the IFF transponder avionic block. Here is the GPS and inertial stuff and the autopilot there. You will have here the weather radar options, and here is the backlighting on the central console. Here are the secondary systems in case of the primary systems failure. So you will have the autopilots and trims secondary switch here in systems. So autopilot, yaw, roll and pitch disconnect. Emergency spoiler over there. Parking brakes, the same, are connected, and the emergency flaps lever. You will also have here the regular flap switch that goes from 0 to 60 degrees of flaps. You also have the oxygen systems for each one of the crew members. So now we are going to go to the overhead here. So you will have here the electric system. Basically it's comprised of the batteries and all the generators labeled G1, G2, G3, G4 and G5. Usually this is done by the flight engineer, but you will have to manage the task of being the flight engineer as well as the pilot of the aircraft. Here is the water methanol injection switches, and here the fuel valves levers. You need fuel, of course, to start your engines. So now we are going to play a little bit with the batteries, and battery 1 and battery 2. We're going to monitor the amps and the voltage. And now we are having some electrical power on our aircraft. And just to show you the alarm, test lights. Now this baby is alive. So right now we are going to proceed with the APU startup procedure. We are going to open the air inlet. Green light is on, air inlet is open. And we are going to start the APU. Low pressure light, the red one, is off. APU RPMs are increasing. As you can see, the hydraulics red system pressures are rising and temperature is rising, so be sure to monitor those and do not exceed the temperatures. And now everything is the green. APU now should be available, so bleed air on. And with the bleeds, we should be able to gather some bleed air for different systems. So basically to cool down the avionics, helps with the starting procedure and as well for the temperature. So yeah, we should just shut down the APU from the turboprops first. This, and this should work. Now we have the APU bleed air, which is available for us if we put it on the on position. So APU bleed air on, and now it's open. Great. Now we are going to basically get the energy from the APU by switching the G5 and basically taking energy from the APU. So G5 is commuted, green light, and we can use and put the transfer keys to on. G1 transfer, G2 transfer key on, 1, 3, 4. And now let's monitor the loads on the batteries. Now the battery is not anymore discharging. So now we are ready almost to start up the engines. We can also show you the EFA system. EADI, EHSI is on. Weather radar. As you can see, this is not the latest technology, but it's a nice aircraft to try to fly. We can align the inertial systems. Start up, let's say, FMS and maybe display the COM page. At first, we are going to implement only the COM page and maybe later implement a more advanced FMS, but as you can see, this is a military FMS, so data can be sensitive.